So just some ideas. Been working on a a few projects lately. I'll outline this idea that there's this cool tool called DBT for data transform tool, and what it does is it allows you to construct like a data marts using SQL and YAML. And let me just illustrate that real quick. What you can do is create models, which are really just tables. And if I go into here, we'll see that there's just like standard SQL scripts, and they contain some Jinja templating, which is kind of like a way to insert variables into everything from Django to Flask to other frameworks. So it's a SQL query, and in association to that, there's these YAML files. So if you know SQL, you can do this. The only other thing is a YAML file, which is a configuration file, and in it we can define things like table names or schemas in the database, table names, and then various tests to run on those columns. And here the test is checking that there's no null values in that column. And I'm not going to go there. I'm going to go to Mart maybe. And we'll see that it's composed of SQL scripts, and here should be a more meaty YAML file. So SQL script, just SQL code, nothing interesting. And then the YAML is where the magic happens. Look at this. We've got a description of the table, and we've got columns with the column names, their individual descriptions, associated tests, such as, no null values and all rows must be unique. And we can use this in combination with this library called Great Expectations. And while that loads, what we can see is that there's more intricate tests. So expect column values to be between A and B. They're out of the box. All we have to do is say dbt.expectation, dbt expectations dot, and then test name, and we can take advantage of all these different canned tests that we can, just pull from this open source pool of tests. And so, it's not like unit testing here. We're just saying we expect that this data accords to these constraints. And as such, what happens is we construct this database using SQL code, or this data mart using SQL code, and the magic happens here. We can set up a CI/CD process, which means when we get pushed to GitHub or GitLab, it as long as we have server support, it'll initiate a new virtual machine, or just create a new compute setup for us. We do initial configurations, and in here we're literally running like command line in terminal to be like pip install this, pip install that, and then run this command in terminal. And so it's really like having your little Linux machine, which you can configure using different Linux versions. You can provide this with a list of different Linux kernels and have forth, and then it just runs all these things, and it builds automatically on the back end, and it posts to the server, or this site. And this is where things are cool. We have ourselves a data dictionary built in, and this is all populated from the YAML files. So we construct the bare minimum SQL, which everybody has and is uncommented and confusing, and dbt takes it from there. You run a command which is dbt seed, and it'll push all the CSV data into the right places. You run dbt build, and it builds all the relationships. Dbt run, and it constructs everything. And so we have all the columns associated with that table. We have all the descriptions, because it's really easy to format. It's just in that YAML file where you type it out, and then all the associated tests. And when you run this, you get a warning, like, or a failure. If these tests don't pass, it brings it to your attention, or it doesn't proceed. And then we see the associated the SQL file that aligns with this YAML on the back end. And then what's also super cool is that, like, we've all struggled with data sources that are highly entangled and we don't understand. But if I click in the bottom right corner here, this little icon, it creates this it creates a directed acrylic DAG graph. But if I go back, let's go back to the maybe here. I'm just gonna, can I do this? Let me look at the big graph. All of the relationships are discovered and processed by dbt, and it gives us this data loading process. So we can see, like, if we have an issue in the dashboard summary table, we just look upstream, and we can see what feeds into these. So it's it's a way to, it's documentation that helps users onboard and inherit a project that might be otherwise quite difficult. So just to say, like, if I change directory back to ACA health, here I'd cd into the transform directory, and in it we have all of the various things. We have the seeds, we have the models, aka the table definitions. We have, like, somewhere in here, profiles will have, like, the credentials for the database, which we can keep in our home directory, so it's secure. But I'd just be dbt seed refresh, and I won't do that right now because it takes a bit of time. But we'd just do either build or everything included. There's, like, a lot of steps that we could execute piecemeal, or dbt run, which we push enter, and it runs all the steps sequentially in the right order. So it's a pretty easy tool to use, and it maintains visibility, transparency, maintains the docs for us. And this isn't working because I haven't switched to the other environment, but, like, I could keep doing this, but I won't waste time because I'd have to change some things around. So that's it. That's dbt. What it gives you is transparency, docs, data dictionary, an automated build process, automated built-in testing, so you don't have to spend a lot of time defining these custom tests. Like, it's all there. You just use it. And it, what do you need? You need to know SQL. That's about it.